Today we are going to learn about creating realistic textures in synthetic data. We will explore techniques to generate realistic textures that enhance synthetic datasets and improve model training accuracy. Welcome to our session on creating realistic textures in synthetic data. In this first segment, we will explore the fundamentals of texture generation within synthetic datasets. Synthetic data refers to artificially created data that mimics real-world data. Textures play a crucial role in this context by adding depth and realism to synthetic imagery. Realistic textures are not just about aesthetics, they significantly impact the accuracy of models trained on synthetic data. In this video, we will cover various techniques for generating these textures, ensuring they contribute to more effective datasets. By the end of this video, you will be equipped with the skills to enhance your synthetic datasets with realistic textures, ultimately improving the performance and accuracy of your models. In this section, we will delve into why realistic textures are paramount for model accuracy. When training models, especially those involving computer vision or graphics, the quality of the data is critical. Realistic textures enhance this quality, providing the model with more nuanced and varied data to learn from. This reduces the risk of overfitting, where a model performs well on training data but poorly on unseen data. By incorporating realistic textures, we can improve the generalization capabilities of our models, leading to better prediction accuracy in real-world scenarios. There are numerous case studies highlighting the benefits of using well-textured synthetic data in model training. For instance, in autonomous vehicle training, realistic road and environmental textures can significantly enhance object detection and scene understanding capacities. Thus, the investment in creating realistic textures pays off in the form of robust and reliable models.
Procedural texture generation is a technique where algorithms are used to automatically create textures. Unlike manual techniques, procedural methods offer scalability and consistency, crucial for large-scale synthetic data generation. These techniques allow for the creation of complex textures that would be time-consuming and difficult to achieve manually. Common procedural methods include fractals, cellular noise, and Perlin noise, among others. These methods provide a wide range of textures that can be used to simulate various real-world surfaces like wood, marble, and terrain. Procedural textures are particularly beneficial in synthetic data as they can be easily modified and adapted, ensuring the data remains relevant and realistic. The future of procedural textures looks promising, with advancements in algorithms and computational power enabling even more realistic and detailed textures. This makes procedural texture generation an indispensable tool in creating effective synthetic datasets. Perlin noise is a popular technique used in the creation of textures. Developed by Ken Perlin, this gradient noise is ideal for generating natural-appearing textures. One of the major benefits of Perlin noise is its ability to create smooth, continuous patterns without the harsh edges that other noise functions may introduce. Its applications in texture creation are vast, ranging from generating cloudy skies to realistic terrain. The seamless nature of Perlin noise makes it particularly useful in synthetic datasets, where the realism of the data is paramount. For instance, in gaming and simulations, Perlin noise can be used to create realistic landscapes and environments. Additionally, it can be layered and combined with other noise functions to produce even more intricate textures. By integrating Perlin noise into your synthetic data creation process, you can significantly enhance the realism of your datasets, leading to more effective model training. Texture synthesis involves creating large textures from small sample patches. This algorithmic approach allows for the expansion of a small sample into a larger, seamless texture. One of the key benefits of texture synthesis is its ability to retain the unique characteristics of the original sample while expanding it to fit larger surfaces. This is particularly useful in synthetic data, where large, realistic textures are often required. There are various texture synthesis algorithms, such as the pixel-based method, patch-based method, and feature-based method. Each algorithm offers different advantages and can be chosen based on the specific requirements of the synthetic dataset. Implementing texture synthesis in synthetic data creation allows for the generation of diverse and detailed textures, enhancing the overall realism and effectiveness of the dataset. By mastering these algorithms, you can ensure that your synthetic data is as close to real-world data as possible, improving model training outcomes. Substance Designer is a powerful tool used for creating textures and materials. Known for its node-based workflow, it allows users to create complex and highly customizable textures. One of the main advantages of Substance Designer is its ability to create procedural textures, which are essential for synthetic data. The tool offers a wide range of features, including the ability to work with multiple texture maps, create dynamic materials, and integrate with other 3D software. This makes it an invaluable resource for anyone involved in synthetic data creation. Substance Designer is used across various industries, from gaming to architecture, to create realistic textures that enhance the visual quality of projects. By utilizing Substance Designer, you can streamline your texture creation process, ensuring that your synthetic datasets are both realistic and effective. The integration capabilities of Substance Designer with other tools further enhance its utility, making it a versatile choice for texture creation and synthetic data. Integrating textures into 3D models is a crucial step in the creation of synthetic data. Textures add depth and detail to 3D models, making them more realistic and visually appealing. There are several techniques for applying textures to 3D models, such as UV mapping, which involves wrapping a 2D texture around a 3D object. While integrating textures, it is important to ensure that they align correctly and do not distort the model's appearance. This can be challenging, especially for complex models, but there are solutions available, such as texture baking and using advanced mapping techniques. Successful integration of textures into 3D models enhances the realism of synthetic datasets, making them more effective for training models. For example, in virtual reality applications, realistic textures can greatly enhance the immersive experience. By mastering texture integration techniques, you can ensure that your synthetic datasets are not only visually appealing but also highly effective for model training. Evaluating the realism of generated textures is an essential part of the synthetic data creation process. Realistic textures are crucial for effective model training, and therefore, assessing their quality is important. There are several criteria for evaluating texture realism, such as texture resolution, color accuracy, and the seamlessness of texture patterns. Tools like texture analyzers and 3D rendering software can be used to assess the quality of generated textures. Feedback loops are also important in this process, allowing for continuous improvement and refinement of textures. By incorporating regular evaluation and feedback, you can ensure that your synthetic datasets remain relevant and effective. Techniques such as comparing generated textures with real-world samples and conducting visual inspections can also aid in the evaluation process. By prioritizing texture realism evaluation, you can enhance the quality of your synthetic datasets, leading to better model training outcomes and improved accuracy.
Thank you for joining us on this journey to explore the creation of realistic textures in synthetic data. Today, we covered the importance of these textures and their impact on model accuracy. We explored various techniques and tools, such as Perlin Noise and Substance Designer, to enhance the realism of your synthetic datasets. By applying the techniques discussed, you can significantly improve the quality and effectiveness of your synthetic data, ultimately leading to better model training outcomes. We encourage you to experiment with these techniques and continuously refine your texture generation skills. Remember, the key to successful synthetic data lies in the details, and realistic textures are a crucial part of that equation. Thank you for watching, and we look forward to seeing how you apply these skills in your projects.